Now let's look at an optimization problem that has a potential pitfall if we are not careful in formulating linear constraints. Here's the setup. A boutique store on beach sells swimming suits and surfboard. The ordering cost for swimming suit is $50 and the surfboard $250. The owner knows from experience that the ratio of swimming suits to surfboard should be no more than 5:1. He makes about $10 on swimming suit and $20 on the surfboard. Given that he has a budget of $5,000, find how many swimming suits and surfboards the owner of the store must have in order to maximize profits. Now, it is straightforward to set up the decision variables, which are just number of swimming suits and surfboard to buy. We do that in row 4. And in row 7 and 8, we put down their inputs, which are unit cost for each and unit profit for each. Now, next comes the constraints. There are two sets of constraints. The first is budget. So we use the sum product to capture the total cost of ordering. That's the sum product of your decision with your unit cost here. And it should be less than $5,000. So that's straightforward. Now look at the next one. It's about the ratio. It says the ratio of swimming suits to surfboard should be no more than 5:1. Someone might be say, okay, that's easy. We just put down here the ratio. I would just say swimming suits is in B4 over C4. That's a ratio is no more than, so less than or equal to 5. Okay, the constraint itself is correct. However, notice that by putting C4 on the denominator, B4 and C4 are having a nonlinear relationship with each other. Okay, let's see the consequences. After we set up the objective, which is just straightforward sum product of the unit profit with the decision, we get the total profit. We are ready to solve it using the constraint we just set up. So let's say solver. So we say maximize our total profit, B15, and changing B4 to C4. And the two constraints are in B11 less than D11, which is the total cost. And let's try the first constraint. So I'm going to click change. B12 less than D12. Right, that's the constraint we just set up as a ratio. Okay, we use simplex for linear programming, and we click solve. Now, after Excel set it up, it gives us this warning: the linearity condition required by this LP solver are not satisfied. So what it means is exactly this constraint. These are not linear anymore. Okay, now is there a way to formulate it as a linear constraint? So if we look at the second one here, if we, instead of saying B4 over C4, which is here, we say B4 minus 5 times of C4 is always less than or equal to 0. So as you could see from the algebra perspective, they are equivalent. However, now B4 and C4 are linear with each other. Now, how about we use this constraint, this linear constraint, to solve the problem? So we modify this ratio constraint, change it to be the second one. Okay. Now we use this second constraint, which is linear. Let's solve it. Now Excel is setting it up, and look what it says. Solver found a solution. All constraint and optimality conditions are satisfied. Let's save the solver solution and look at. So indeed, it find we should order 50 units of swimming suit and 10 units of surfboard, and we are able to get a good solution using linear constraint. So one should be careful in how to formulate the decisions and the constraints always try the best you can to formulate it as a linear one, as it will guarantee a solution if it has a feasible one.